Hi, I'm Alice Klein, and with my collaborator, on behalf of my collaborator, Prentice Starkey, and myself, we want to welcome you to our session, Strategies for Addressing the Gap in Early Math for Our Youngest Learners. Prentice Starkey and I are senior project directors at West Ed. The agenda for our presentation today is divided into 4 sections. The first section will discuss math gaps among our nation's youngest learners. The second section will talk about some research on the negative impact of the pandemic on early math learning. Then we will discuss how effective Tier 1 math interventions can positively impact early math learning. And in the last section, we will present research on an intensive math tutoring intervention to support low-performing children. The resources related to this presentation are available in the resource room. Now I'm going to turn over the presentation to Prentice Starkey.
Okay, hello, I'm Prentice Starkey. Let's begin with the math gap. Math gaps, or group differences in mathematical knowledge, emerge early, and they're larger for SES than for other demographic characteristics like ethnicity or gender. The SES math gap, it begins to develop early by 3 years of age, and it widens over time. By the end of PreK, the gap widens to approximately 1 year. I'll show you a figure on that in just a moment. In kindergarten, the gap between the lowest and highest quintiles of SES is 1.3 standard deviations. These are large differences at such an early age. So here's a figure. The longitudinal data on children, low SES and higher SES, which is middle and upper middle SES children. Children were assessed on math beginning their pre-K year of preschool when they were 3, all the way through those 2 years of preschool, ending when they were old 4-year-olds. You can see that the gap is already present when they enter at age 3, and the gap widens over time. If you'll notice the 0.5 line on the CMA score, that means children who got half the items correct. Notice when the higher SES children reach that point. It's when they finish the pre-K year. Now look at the low SES children. When do they reach that point? You'll see they approach it at the end of the pre-K year. So this is a gap of about 1 year that we see in these children. How does the gap originate? We know from research that it stems, at least in part, from different levels of support for math in children's early learning environments. There are ineffective math components in the comprehensive curricula that are used in many public preschool classrooms. And you can look at the WWC ratings for that information. There's also less math enrichment in the home learning environment. There's been a great deal of research on this that's shown that math support at home varies. I want to now report a natural experiment on the impact of the pandemic and school closures on young children's math learning. The way this experiment came about, back in 2019-20, we were conducting an evaluation of an early math intervention called PreK mathematics. I'll talk about that later in the presentation. We were doing this at a national level of scale, beginning in 2019-20. That year, we were in the states depicted in the southern half of the United States. Children were pre-tested in 2019, but schools closed abruptly during the winter due to the pandemic. Programs were closed the rest of that year. The following school year, they then reopened in 2021. We looked at children from the same programs who were involved in 2019, looked at those children when they entered pre-K. And the question was whether these young 4-year-olds just entering pre-K, whether their math knowledge differed by virtue of being out of their programs for 1.5 years. So what we're really looking at is math change that occurred when the kids were 2 or 3 and they lost early Head Start, or their state-funded preschool program due to the pandemic. You'll see on this first figure, children overall, there was a math drop. Overall, the sample dropped 8%. Urban children dropped greater, more of a loss for urban children than for rural children. Now let's look at a couple of demographic groups. You'll see that both Native American and Black children fell in their math knowledge, Black children more than Native American children. So the conclusions we're going to draw from this is just that young low SES children enter pre-K with less math knowledge after the pandemic than their peers did before. Some groups, in particular urban and Black children, drop more than others. I should point out the Black children are Southern Black children primarily. The Native American children are primarily in the southwestern US. This finding has implications for the grade cohorts of children who should be targeted for academic recovery measures. Young children who experience the pandemic should receive effective math interventions to help them catch up later in school. I want to now talk some about the role of early intervention in closing this math gap. And as I mentioned earlier, young children's opportunities to learn math tend to vary in accordance with their family's socioeconomic status. To address this, researchers have developed early math interventions for preschool and early elementary grades that enrich children's learning environments. We've developed and evaluated one of these interventions, PreK Mathematics, which is a Tier 1 curriculum that supplements the comprehensive curricula and widespread use in public preschool programs. As you can see here, Pre-K Mathematics is designed to enrich both the classroom and the home learning environment. Classroom is enriched primarily through small group activities that teachers conduct, the home component from dyadic activities that parents or other adults conduct with children at home. We also have a professional development component. It uses a trainer of trainers model where there are teacher workshops, on-site support by curriculum coaches. Teachers receive this support in their classroom, and as a trainers institute for training local curriculum coaches to give the program some lasting capacity. This is what a small group activity looks like. These children are learning to make a tetrahedron or a triangular pyramid, and the teacher's talking to them about features of the pyramid. The main objectives and key features of pre-K mathematics are first, the learning objective is for children to develop a broad foundation of informal mathematical knowledge. They'll bring this foundation with them when they reach kindergarten and start learning more formal mathematics. The content of the activities used in the curriculum are aligned with broad recommendations about the content of preschool mathematics instruction. This is a developmental curriculum, meaning that it addresses the needs of individual children. This is done through scaffolding, help provided to children as they need it. If they're doing an activity, downward extensions for children who aren't quite ready for the main activity, and upward extensions for children who complete the activity with ease and are ready for something a little more challenging. And this way, the developmental needs of all children get met. All children grow from this. Teachers monitor the delivery of curriculum dosage. This is important for intervention. Teachers also monitor the progress of individual children toward mastery, where the goal is for children to reach mastery, meaning independent problem solving. They can do the activity by themselves. The curriculum coach's main role is to support teachers' instruction during teachers' first year of use of the intervention. This slide talks about the evidence of effectiveness. We'll put this in the resources room, but you can see that the What Works Clearinghouse has given this intervention its highest rating of effectiveness, Tier 1. We've done multiple RCTs, and we've done two RCTs where pre-K mathematics was paired with Common Core aligned kindergarten curriculum. And we found in both of these RCTs that the math gains in pre-K were maintained throughout kindergarten. This is just data on one of our IES studies to show you what the gains look like. The two lines at the top are treatment children, different cohorts. The bottom line's control children, business as usual, no pre-K mathematics intervention, just the classroom curriculum. You can see that. And then finally, the figure I showed you originally, I have that there, and we put data from one of the intervention studies on it. And if you look at age 4, the green line, these children start out even a little lower in the pre-K year, and you can see the extent of the gains there. If there's time during the question and answer period, you say I've got an orange square there, and I can provide some more information about yet another intervention model that we've used. And now I'll turn things over to my collaborator, Alice Klein.
The research that we've presented thus far shows how an effective Tier 1 math intervention can support low-performing children. But some children show a low response to an effective Tier 1 math curriculum. So as you see in this figure, it presents the growth in math scores from the fall to the spring of the pre-K year. The solid lines refer to children who receive the math intervention. The dotted lines refer to children who are in a business as usual control condition. And what you can see is in the purple solid line is the growth over the pre-K year for children who are in the top 3 quartiles of the treatment condition. But then the solid green line, which is closer to the bottom, shows children who are in the lowest quartile of the treatment condition. And you can see that they are not responding or showing a very low response to what is otherwise an effective tier math intervention. So we know that Tier 1 curricular interventions were developed to provide an effective math instruction for the general population of pre-K children. However, it appears that a subgroup of pre-K children demonstrate low response to generally effective Tier 1 math curricula. Without a more intensive intervention, these low-performing pre-K children will not have the knowledge and skills needed to meet kindergarten math standards, and this will put them at risk for math difficulties and on track for special education services in early elementary school. In response to this finding, we developed pre-K mathematics tutorial, which is an intensive tutor-based math intervention to support the learning of low-performing children. Pre-K mathematics tutorial was designed to provide more intensive instruction on a core set of math concepts and skills using concrete materials and especially introducing mathematical language. The objective is to help low-performing children build a strong foundation of informal mathematical knowledge that they will then be able to transfer when they go and learn more symbolic or formal knowledge in elementary school. The primary focus of the intervention is on number and operations, but we have a secondary focus on spatial and geometric concepts. This intervention is comprised of 20 activities. There are foundational activities, there are approximately 10 foundational activities that are typically implemented in the fall, and then 10 more advanced pre-kindergarten activities which build on what they have learned in the fall that are presented in the spring. There's a new activity presented each week, and then there are 4 weeks of review that are interspersed throughout the curriculum plan. So there are some key features that were built into the development of pre-K mathematics tutorial that we know support low-performing children. First of all, tutoring increases the intensity of math instruction in addition to, not taking the place of, but in addition to Tier 1 math curriculum in the classroom. It follows a carefully sequenced curriculum plan. It provides systematic instruction with modeling and scaffolding if children make errors. It prioritizes teaching to mastery, not just exposure, and uses a tool to monitor children's progress towards mastery on each activity. And finally, it incorporates cumulative review into the curriculum plan. And we know from the research on low-performing children that these are key features that help them succeed in their math curriculums. Here's a picture of a tutor working with 2 children. They work in pairs, working with 2 children on a quantitative comparison activity where they are comparing 2 small sets, in this case, a set of 5 stars and a set of 2 stars, and they have to determine which set, whether it's the set that belongs to the giraffe or the set that belongs to the elephant, has more. And here's an example of a tutoring activity that involves spatial and geometric concepts. This is Watch Me Make a Shape 2D, and the children are given a set of clay balls and sticks. The tutor puts out a model. You can see the model in the foreground of an equilateral triangle, and they have to construct a triangle with clay balls and sticks, just like the model's triangle. And then the tutor will talk to them about how many sides they have in their triangle and how many corners. So it involves both constructing and analyzing the components of 2-dimensional shapes. Now I'm going to present a video clip of an activity that's from the pre-kindergarten part of the curriculum. It's called How Many Dinosaurs? And in this activity, the children have to solve simple addition and subtraction story problems with objects, in this case, dinosaurs.
Perfect. Okay, guys, we're going to use our listening ears and we're going to watch with our eyes, okay? So, we're going to play a game with the dinosaurs, okay? So, each of you will get a set of dinosaurs and a map for the game, okay?
Okay.
So, right here, these are your dinosaurs. So, let's look right here. So, this is your forest.
It's gonna be fun.
Yeah, it is. So, let's pay attention here. So, this is your forest and this is your lake. Can you point to the forest for me, please? Awesome. And can you point to the lake? Awesome. Okay, now you point to the forest. Awesome. And can you point to the lake? Good job. Okay, great. So, I'm going to tell you some stories about dinosaurs that like to eat plants in the forest and drink water in the lake. So, yeah.
That's yummy.
It is yummy. So you will get to act out the stories with your dinosaurs. So listen carefully, and I will tell you what to do with your dinosaurs, okay? So 5 dinosaurs walk into the forest. Take 5 dinosaurs out of the bowl and put them into your forest.
Yeah.
Yeah.
How many homes do they have? A lot.
Yeah. So take 5 dinosaurs out of your bowl and put them in your forest.
One, two, three, 4, and last in it, 5.
Okay. Awesome. Okay. So now let's listen. Now, one more dinosaur comes into the forest to join his friend. Take one more dinosaur out of your bowl and put it in your forest.
6.
Awesome. So how many are there?
6.
Awesome. And Kevin, how many dinosaurs are in the forest altogether?
1, 2, 3, 4, 5, 6.
How many?
6.
Awesome. Okay, so now all the dinosaurs leave the forest to go back home. Take all the dinosaurs from your forest and put it back into your bowl. Now we're going to play the dinosaur game in a new way, okay? You will use your dinosaurs to act as the stories by yourself. I can help you if you need it. So now, 6 dinosaurs walk into the forest. Awesome. Okay. So now let's listen. Now, 2 more dinosaurs come into the forest to join their friends.
Okay. They play tag.
They play tag, yeah.
Yeah, they love. Dinosaurs love playing tag.
They love playing tag, yeah.
Yeah.
Okay. So let's do this together, okay, guys? Put
Okay.
them back right here. Thank you, Kevin. So, 6 dinosaurs go into the forest. Take one dinosaur at a time and count with me. So let's do one at a time. 1. Count with me. 1, 2, 3, 4, 5, 6. Awesome. So now let's listen here. Okay. Now 2 more dinosaurs come into the forest. Take 2 more dinosaurs from your bowl and put them into your forest. 1, 2. Okay, so Santino, how many dinosaurs are in the forest altogether?
6.
Can you count them for me?
1, 2.
Let's count together, okay? So follow my finger. 1,
8.
2, 3, 4, 5, 6, 7, 8. How many are there?
6.
There are 8. Can you say 8?
8.
Awesome. So how many dinosaurs are there in the forest
8.
altogether? Can you
8.
count them for me?
1, 2, 3, 4, 5, 6, 7, 8.
How many are there?
8.
Awesome. So now all the dinosaurs leave the forest to go back home. Take all the dinosaurs from your forest and the lake and put them back into your bowl.
This game is very fun.
Yeah, it's fun. Awesome. Okay.
So now that we've seen some examples of what the foundational and pre-K activities look like, we want to know if the pre-K mathematics tutorial intervention works. Does it work? And my collaborator, Marcia Barnes at UT Austin, and I conducted a rigorous efficacy study of this intervention that was funded by IES. The study was conducted in public preschool programs in Texas and California. We started out by screening all the pre-K children in participating classrooms on a math measure at the beginning of the year. The math screening measure was designed to predict those children whose kindergarten performance on a standardized test would be below the 25th percentile, and that's a score which indicates low math achievement. The total sample in this study consisted of 541 children who were screened and met this cut point. Their mean age was 4.5 years, and you might notice that about 48% of the children were English learners. It is Spanish speaking predominantly, and they were more in California than in Texas. And I want to point out that this is a very low performing sample. 75% of the children scored at or below the 6th percentile on a standardized math test in the fall of pre-K. So a brief overview of the design and procedure. Children in the sample, this was a randomized controlled trial, children in the sample were randomly assigned to one of three conditions within each participating classroom. There was a math tutoring condition. They received math tutoring 4 days a week. A second condition received math tutoring 4 days a week plus attention training. And the third condition was a business as usual control. Children were tutored in pairs on the math activities outside of the classroom, and each math session lasted between 15 and 20 minutes. And it's important to note here that all the children continued to receive their Tier 1 classroom math instruction. So the primary research question that we're asking in this study is whether low-performing children who receive pre-K mathematics tutorial intervention with or without attention training demonstrate more growth in their math knowledge at the end of pre-K than low-performing children who received business as usual instruction in their pre-K classrooms. And that would mean that they simply got their Tier 1 math instruction, but they were not getting any specialized Tier 2 instruction for low-performing children. And here's to preview a graph that shows the results. The blue is conditions, is the math and attention condition. The red bar is math only, and then the green is the control condition in Texas and California. And these are their math scores by condition and state, corrected, of course, for their pretest scores. And what you can see here is that the both math conditions, whether it was math and attention training or math only, were significantly greater in their math scores than the control condition. So we had two principal findings that I want to point out here. We had a main effect for the math tutoring intervention. That is, low-performing children who received PKMT with or without attention training had significantly higher math scores at post-test than children in the control condition, and this effect was found across both states. And it's a pretty significant effect size of 0.52. We also got a main effect for state. And that means that the math scores on average across all the conditions were higher in Texas than the math scores in California at post-test. And this finding indicates the importance of the Tier 1 math instruction, which was stronger in Texas than in the California classrooms. So a few key takeaways here. This was the first study to test the efficacy of an intensive tutor-based math intervention and using it as an academic strategy to improve the math learning of low-performing pre-K children. The findings demonstrated that the math tutoring intervention was effective for a subgroup of young children who enter pre-K with very low math knowledge. This study has been reviewed by the What Works Clearinghouse. It met their standards without reservations and was rated as providing strong evidence of effectiveness by ESSA. The difference between states, however, also underscores the point that the intensity and quality of the Tier 1 math instruction also matters for supporting low-performing children. And I want to sort of raise one challenge if you adopt a tutor-based approach to support low-performing children. It can be very difficult to recruit and train tutors. And my collaborator and colleague, Kylie Flynn, and I are currently testing whether teachers can deliver the pre-K mathematics tutorial effectively in their classrooms, which would be a very beneficial approach for schools to use. And so stay tuned for the results of that study. As in conclusion, we want to say that we believe that a multi-tiered system of support for early mathematics is what is going to be needed to improve mathematics learning for the population of early learners, those who are in the general population as well as those who are low performing. And a multi-tiered system of support is intended to optimize student learning of math. The Tier 1 intervention is designed for the general population of pre-K students, and the Tier 2 is designed to provide more intensive support for students with greater learning needs than a Tier 1 math intervention can provide. Thank you.